We thank you for the gift. We thank you for the gift of life. We thank you for the gift of our parents, our caretakers, and especially for granting us the grand opportunity of being able to attend this lesson. Help us to be able to perceive everything we are going to study today. And may you give us retentive memories that can grasp everything that we study. And may you grant us success in our studies. Amen. Grant us a good day today and bless all the people that we encounter in our days. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Okay, thank you, Priska, for the word of prayer. Good afternoon, everyone, and thank you so much for joining. Those that were here last week, we started on partial fractions, and we were able to look at one case. And today, our focus is going to be on the other cases. Still, our competence is being able to decompose the rational expressions, and our learning outcome for our session today, still we are going to focus on how we decompose a proper fraction. However, in case time allows, we shall go on and also look at improper fractions. But in case time does not allow, we shall stop on proper fractions. But now we are going to look at the second case. Last time we looked at the case and we say that before you decompose any fraction, you must first ensure that the fraction you are dealing with is a proper fraction. And we say that one way to test whether a fraction is proper. Can someone remind us? You can raise up the hand and you tell us, how do you test or what do you base on to say that this fraction is proper, this one is not proper? Anyone to just recap for us a bit? What do you base on? Okay. Yes, Martina.
So if you want to know whether the fraction is proper or improper, we look at the numerator and the denominator. So if the degree, okay, we were using the degrees last week. So if the degree of the numerator is bigger than the degree of the denominator, let's say the degree of the numerator is 1 and the degree of the denominator is 2, then it would be a proper fraction, and vice versa for improper. Yeah.
Okay, thank you so much, Martina. That is correct. Okay, so that is what we are going to base on today, still to continue with our second case. Now, what is our second case? Our second case, the keyword today is going to be repeated. Last time, we were looking at fractions which didn't have repeated linear factors. And when you hear the word linear, linear means like straight line. And now here, when we are looking at linear factors, we are going to look at factors whereby the power, the highest power is 1. Take an example. When I look at x plus 2, this is what we call a linear factor. When I look at maybe 2x plus 4, still this is the linear factor. You look at the value of the unknown, of the variable, or the value of x. The moment you find that the power is 1, then that means it is a linear factor. However, we are going to look at those linear factors that are repeated. By repeating, take an example. When I have x plus 2, everything squared. This one means that x plus 2 is twice. So it means it's x plus 2, x plus 2. It is multiplied twice. And this is what we call repetition. In case I have 2x plus 3, maybe power 3. It means that this linear factor is going to be written 3 times 2x plus 3, 2x plus 3, 2x plus 3. So this is what you call repetition of the same thing, but written a number of times. Now we are going to look at those factors which are repeated very many times and how do we deal with them. So that is going to be our first case that we are going to look at today. Now, when it comes to decomposing such factors that are repeated, we shall be following this key point. I'm going to first give you an example. Take an example. I have px plus q, and this is maybe, okay, let me give you real values. I have 2x plus 3 out of x plus 1 squared. When you look at what we have in our denominator, you notice well that this is a proper fraction, because the moment you open the bracket here, you'll find that the highest power is down. Therefore, when we are expressing such in form of a partial fraction, we shall first have our constant divided by x plus 1. But the power here, the power on the highest power on the linear factor will always tell you how many partial fractions can be generated. In case there are 2, the highest power is 2. It means that you write it 2 times. So it means we shall have plus b and then out of x plus 1 squared. You notice that we are expanding the powers. The first one was power 1, now it is power 2. Similarly, if I have 2x plus 3, maybe out of x plus 1 power 3. When I'm expressing it in terms of partial fractions, I'll still say a out of x plus 1 plus b out of x plus 1. Now it's going to be squared, then plus c out of x plus 1, then power 3. That is when the power is 3. So this is how we are going now to be expressing them. In the moment you find out it is a repeated factor. Even if they are 4, even if they are 5. So in case they are 4, it means that you separate it 4 times. In case they are 5, you separate it 5 times. Sometimes it can also be combined, whereby you can have 2x plus 1, maybe out of x plus 1, and then I have x minus 2 squared. When you look at this one is not a repeated factor, but x minus 2 is a linear repeated factor. So now when you are working out this repeated one, still you do the same thing. So I'll first say a out of this one that is not repeated, which is x plus 1. Then I say plus b out of x minus 2, then plus c out of x minus 2, then power 2. So you expand it in bits until when you reach it. So this one means you write it 2 times. In simple terms, in case it is 3, it means that this part that is repeated, it will be separated into 3 times. Class, are we on the same page? Let me know through the chat. Are we on the same page? Now looking through the chat. Okay, now not yet. I'm lost. Okay, now I want to repeat. I repeat. When we have repeated factors, a repeated factor is like when you have x maybe minus 1 squared. This is what we call repeated factor, because it means x minus 1, that is the meaning. Remember, when we are expressing these proper fractions, the first one we looked at the case, we looked at linear factors. So this is 1, this is twice. So it means it is written twice. But when you look at it, it is the same. Now, when you are expressing it in terms of partial fractions, you remember at first, let me say you had x plus maybe 1, and you had x minus 1, x plus 1. When you look at the 2 factors we had initially, the first case we looked at, these were different factors. This is x minus 1, this is x plus 1. These factors are different ones. And we say that when we are expanding it, we shall say a out of x minus 1, then plus b out of x plus 1. But these factors we looked at, they were not repeated. They were not the same. So that's why we separate them like this. But for cases where you are going to find that the factors you have are repeating, let me say x minus 1 squared. For such cases, when you are expanding it, you expand it in a special way. And that special way is going to be, you write your a, the way we are writing it, out of this one. But now you look at the powers, you expand the powers. So I'll have x minus 1, then plus b out of x minus 1, then squared. So your task is to increase the power from the lowest power, which is from the lowest power up to the highest power. So we shall start with 1 because any number power 0 is 1. So that one we ignore. So we start from 1, then 2. But there is no need for you to write 1. In case I have, let me say 2x minus plus 3, and I have x plus 1, this is maybe cubed. Still for this case, what will you do? You write a out of x plus 1 the first time plus b out of x plus 1 squared plus c out of x plus 1 then cubed. So you notice that this highest power on your denominator tells you how many times that fraction is going to be separated. So it means that if I have 3, I write my partial 3 times. I will divide my proper fraction into 3 times. In case the power down is, let me say, x1 plus 4, it means that you're going to separate it 4 times. So you write, maybe in case this is maybe 1, so it means that you write a out of x plus 1 plus b out of x plus 1 plus c out of x plus 1 cubed plus d out of x plus 1 power 4. So that's how you expand it. I don't know whether now we are on the same page. Are we on the same page? Okay, now I'm going to invite you now to first make some notes. First make some smaller notes from this page. Yes, Prince Sam.
Good afternoon, everyone.
Yes,
And
good afternoon.
so my question is simple. Like, why are we leaving the powers on yet we have expanded it?
Why are we?
Leaving the power on it, like x plus 1 into bracket squared.
Okay. I'm going to demonstrate that using an example.
Okay, sir. Thank you, sir.
I'm going to demonstrate it using an example. Okay, just make some small notes from here. When you finish, we shall continue. Yes, Jordan.
Master, good afternoon.
Good afternoon to you.
Actually, I'm not getting these things. Is it that the first case was the other things that they covered with partial fractions?
Yes, is this your first lesson?
Yeah, this is my first lesson of math. Last time I came when ending.
Okay, I think that is where, but you're going to get, don't worry. The moment we start looking at the example, you'll be able to pick, eh?
Okay, sir.
Mm.
Good afternoon, sir. Good afternoon, sir.
Good afternoon to you.
So me, I was asking, why do we, after decomposing the fraction into three, when you have been given an exponent of 3, why do we remain with the exponent?
Okay. Okay, I'm going to demonstrate that using an example. I'm going to demonstrate using an example. Why we remain with it. Because at the end of the day, when you're working out partial fractions, you must ensure that what you have on the right and the left are the same. When you compress what you have on the right and what you have on the left are the same. Now, one of the reason is that when we are dealing with the partial fractions, what I have, this is my this is which hand? This is my left hand side, and this is my right hand what side? You must make sure that the LCM, the LCM this side is the same LCM you have this side. Those two must be the same. So when you check very well, the LCM you have this side is ax plus b all of it squared. The LCM you have this side is going to be the same. So that is one of the way. Because at the end of the day, now let me use this slide here to explain it well. At the end of the day, let me use this one, 2x plus 1. This is just an example, members. Don't worry, no worries. Remember, I've said this is a out of x minus 1 plus b out of x minus 1 squared. One of the things we always aim at when we are solving, we are aiming at that the denominators do vanish after you have simplified. So you must ensure that the LCM, what you have as your LCM on the left-hand side, is the same LCM you have on the right-hand side. That is when now you have your function you will not have a fraction. You would have eliminated it. So the LCM of this side, you can note that the LCM is x minus 1 squared. And also when you check this side, you remember, those who remember how to get LCM, this is x minus 1 squared. This is x minus 1. So when I'm dividing, I will say by x minus 1, here you have 1. Here you have x minus 1. Then by x minus 1, I'll have 1. I'll have 1. So meaning that the LCM on my right-hand side is going to be x minus 1 2 times because you multiply the 2. And that is one of the things you'll aim at. But if you ignore this exponent here, you will notice that your LCM is going to be x minus 1. Meaning that if when you reach the part of solving, you are going to remain with a fraction somewhere. So you'll have something like you remain with a fraction somewhere. So you'll not have decomposed it completely. Let me hope that one is clear why we leave the exponent there. Is that okay, members? About the exponent? Okay. 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 Now we are good to go. Okay. Okay, now we are going to start on our first example or first activity. And our first activity is going to be this number here. We are going to try. So the first number we are going to deal with is going to be 8x plus 9 out of x minus 3, everything squared. Now, like we have said, what do? We are going to first decompose it. So we shall say that this is 8x plus 9, everything x minus 3 squared. We say this one we use the equivalent to having our a out of x minus 3, then plus b out of x minus 3, everything squared. That is the first step. Then, now, I want to teach you something now today, something very new. Now, one of the things now I can use, last time I told you when there are two, you can just cross multiply, which is very okay. Now, when we have repeated factors, what do? You can quickly look at what you have this side. Are you seeing what you have as your denominator? What appears as your denominator? Now, what appears as your denominator? You multiply it through out the whole equation. So I'm going to say multiply through by what I have as my denominator, which is this. So what is going to happen? Let me hope we're on the same page, meaning that I'll come here, I'll multiply here by x minus 3 squared. I'll come here, I multiply by x minus 3 squared. I come here, I multiply by x minus 3 squared. Class, first let me know whether we're on the same page. I don't want to leave anyone behind. Is that very clear? Are we on the same page? Okay, people saying yes. Now, what is going to happen? Class, you are going to notice that this and this are going to cancel. Then you notice that here, there is, these are 2, this is 1. So I'll cancel 1, and also here, I reduce. So here up, I'm going to remain with only 1 of it. Then here, this and this are going to cancel. So you are going to notice that at the end of the day, I'm going to remain with 8x plus 9 equivalent to A into x minus 3 plus B or alone. Now, the moment I reach that step, it means okay. Now, once we reach that step, we say the easiest thing to do, you have 2 options. Either to use what we call the substitution method or what we call the equating method. So allow me to use the substitution method. And we say that when it comes to the substitution method, for you look at what you have on your right-hand side. That here I have x minus 3, and is the one I want to die. So we say that what you do, you get that factor you have, x minus 3, equate it to 0. So meaning I'll have x minus 3 plus 3 equals to 0 plus 3, and you say x is equal to 3. Meaning that here, what am I going to do? I'm going to come and I say, I'm going to come here and I say, let my x equals to 3. Now, the moment you get that factor that you are going to use, what are you going to do? You are going to get that value of x. Then you put it. You are going to get that value and then you put it in this equation. So I'll have 8 times 3 plus 9 equaling to my a now into 3 minus 3, then plus b. So 8, then here you just place your calc and you say, what is 8 times 3? 8 times 3, which is 24, plus 9 equaling to, this one will give us a 0 plus b. Then 24 plus 9 will give us a 33. So I'll have 33 equaling to b. So I have obtained my value of b. Now, after obtaining your value of b, you can go on and get the value of a. Okay. Let me first give you a chance to try. Just Okay. Now, after obtaining your value of B, we need to go on and obtain okay. Now, after obtaining the value of B, you're going to obtain the value of A. Now, what do? You can come and use this equation that we have formed. So I can come here and I say 8x plus 9 now will equal to A into x minus 3. But my B, I have obtained it as 33. Now, once you reach at this point, please always feel free to use any value of x of your choice. So take an example, I can say, let my x equals to 0. So I'll put everywhere. So I'll say 8 times 0 plus 9 will equal to A into 0 minus 3 plus 33. So here I remain with 9 equals to this side. I'll have negative 3A plus 33. Then you are going to go on and then collect like terms. So when we take the 33 this side, we shall have 9 minus 33 equaling to negative 3A. So 9 minus 33 gives us negative 24, which is equaling to negative 3A. And therefore, when I reach that point, I'm going to divide by negative 3. So I'll have negative 24 divided by negative 3 equals negative 3A divided by negative 3. So when you get 24 divided by 3, you end up with that is 8. So 8 will equal to A. So that's how you obtain your A. Now, for this second part, whenever you find that you have no any other factor, always feel free to use any of your choice. As long as you don't use 3, because the moment you use 3, A will vanish. Okay, now I repeat, I have said that the reason why we do have a squared on our right-hand side, it is why we keep on having that exponent, is that we must ensure that the LCM we have on the left-hand side is the same LCM on the right-hand side. The moment you do not put that square, it means that you are going to have a less, like the LCM is not going to be the same. So meaning that when you are going to reach a point whereby you still work with fractions, of which now we want to eliminate them. Now, after obtaining your A and obtaining your B, we can go back and then substitute them. Okay, so substitute them back and then okay, so that is what you have to do. So at the end of the day, we are going to come back and I write now my answer. I'm going to come back here and I write now, this is going to be equivalent where there is A, we shall put 8. So we shall say 8 out of x minus 3, then plus B. Oh, but we have also obtained our B. Our B was 33. So I say 33 out of x minus 3, everything squared. And that is how you will conclude for your answer. I don't know whether we're on the same page or... Yes. Okay. Paper saying we're on the same page. We said we have two approaches we can use. You can use this equating approach, or you can use the approach of equating the coefficients. Yeah. So those are the two approaches that one can use. So it is up to you which one is easier and which one will make your life a bit easy. Yeah. So that is what you should always look at. So first, okay, if we are on the same page, you let me know, and then we try out another number. Okay. Okay. Okay, I think I'm going to same page. Okay, so allow me now to move to we try another number in the same caliber. Okay, Now, another number, I'm going to clean this screen. Another number I have is here that I want us to try. I have 3x plus 1 out of x minus 1, everything squared. Now, those who are lost, please, let us concentrate now on this part. Those who have picked, now for you, let us do on our own, as I support those who have not yet obtained the concept. We have said that the first thing we do, we are going to equate, and we shall say this is the same as a out of x minus 1 plus b out of x minus 1, everything squared. Now, but before I put a square, you will note that the moment you don't put a square here, it will mean that the LCM are going to be different. So in your solving, you are going to find challenges working with the fractions. Now, when I'm going to put a squared, but I've told you, when you find it to this side, it means that your partial fraction is going to be divided into two times, or it's going to be decomposed twice. That is the meaning. Then we say that the moment you reach at this step, what do? Always look at what you have as your denominator in the original fraction. That is what you are going to multiply with. So I'll say multiply through by x minus 1 squared. That is the step. So we are going to multiply. Now, I'm going to first write my original one. This is x minus 1 squared. We are going to multiply. So we have said we multiply through. You look at what you have in the denominator. So we are going to multiply here by x minus 1 squared. We multiply here by x minus 1 squared. We multiply here by x minus 1 squared. Now, what are you going to note? You are going to note that we have two things that can reduce. This one here and this one can reduce. Then you notice that this is x minus 1, x minus 1. So this and this are going to reduce. But here, since they are two, one of them will remain here. So I'll have x minus 1. We have said x minus 1 squared divided by x minus 1. You can use your indices and say this is to power 1, and therefore I will have x minus 1, 2 minus 1, which will give me x minus 1. Alternatively, you can come and say x minus 1, and I'm dividing it by x minus 1. So one of them cancels, I remain with 1. Then here, this and this are going to reduce. So what am I going to remain with? It means that I remain this side, I remain with 3x plus 1 equivalent to a into x minus 1, then plus b. Now, the moment you reach here, there are two approaches you can use. The first approach is the approach of equating. The second approach is the substitution approach. But I'm going to use, for this number, I will use both methods. Now, what do? We say that when we are just equating, we always look at on the right-hand side and we look at the factors. That our factor is x minus 1. And now we ask, what do we want to remove? That we want to eliminate this a. You want a to go away. So the only way a can go away is when the whole of this thing multiplying it is 0. And how can we make it 0? By saying x minus 1 is equal to 0. And therefore, my x will equal to 1. So that means you are going to first let your x to be 1. So we shall say that let x equals to 1. Now, the moment x is equal to 1, let us substitute. So we shall come and say 3 times 1 plus 1 equaling to a into 1 minus 1 plus b. So 3 times 1 is 3 plus 1 equaling to a times 0 plus b. So this will give us 4 equaling to b, because a times 0 is 0. Now, after obtaining your b, you can now go on and say, let me obtain my a. You go back to the same equation. You say 3x plus 1 is equivalent to a into x minus 1 plus b. Now, if you have just two unknowns, here we have said you can use any value of x of your choice. And the best one that for me I usually use is when it is 0. So I can say let x is equal to 0. But whether you have used 0, whether you have used 15 or 100, you'll get the same answer. The only value you shouldn't use is the value of the factor, because this one for the factor, it means that your a will vanish, yet that is what you wanted. So when x is equal to 0, I have 3 times 0 plus 1 equals to a into 0 minus 1 plus b, which is 4. So I'll end up with here 1 equaling to a times negative 1 plus 4. So I'll have 1 minus 4 equaling to negative a. So here I will remain with negative 3 is equal to negative a. And when I divide both sides, I'll have my a equals to 3. So that is how you can approach it. Now, alternatively, method 2, those who want to use the second method of equating, I'll have 3x plus 1 equivalent to, you are going to allow me to open brackets, ax minus a plus b. What do you do? When it is equating, equate corresponding coefficients, that x with those with x, those without x with those without x. Now here I'm saying coefficients, I will say coefficients of x. Now, what are the coefficients of x? This side, I have 3. So I'm going to equate to a. Because this 3x goes with the ax. So my a will be 3. Then I go to those without a. I say constant for constants. For constants, this side I have 1. I will equate to negative a plus b. But what is my a? My a, I've obtained it as 3. So I'll say 1 is equal to negative. This one is going to be negative 3 plus b. When I take the negative 3 this side to be 1 plus 3 equaling to b, and I have 4 equals to b. That is the second approach in case that's what you want to use. Then at the end of the day, all approaches give you the same answer, but always use the one that is easy for you. But all of them will give you the same answer. And therefore, we shall conclude and say 3x plus 1 out of x minus 1 squared will be equivalent to a, which is 3 out of x minus 1, plus b, which is 4 out of x minus 1, everything squared. Now, in case you have any questions, in case you feel we are not on the same page, kindly you can ask, but I'm very happy I'm seeing the answers in the chat. Yes, yes, any method you want. I've showed you the second method, any method you want. Yes, iPhone.
Good afternoon, sir.
Good afternoon.
Yeah, my question is about the first statement in method 2. When we introduce the minus, that part of ax minus a plus b, why not plus? Yeah.
Oh, now, iPhone, are you here? I'm not introducing it from the blue. It is here, here. Look here. Are you seeing this?
Yes.
When you open brackets, this a multiplies the x, you get ax. This a multiplies the negative 1, you get minus a. Then you add on this.
All right.
Okay. Yes, Paul? Paul?
Yes, teacher. I hope you can hear me. I was wondering when we change the equivalent sign to equals, because last time you said when we do not have a and b, and let's say we have the values, in this case we have 3 and 4 as a and b. In the beginning we use the equivalent sign, and then last time you said in the final answer we use the equal sign, but then here you're still using the equivalent sign. So which is which?
It doesn't have
Because
any problem, Paul.
it's the same thing.
Yeah, just to show you that this one is the same as the other thing.
Oh, okay, teacher. Thank you.
Okay. Yeah, but Paul, still it will depend on the book you are reading. Yeah, some books, it will depend on which book we are using. But what we are just showing is to show that this side is the same as the other side. Yes, Jen?
Excuse me, teacher. I'm lost at the first step why the denominator on B is x minus 1 squared.
Yeah, I've said that when we are expanding or when we are decomposing the partial fractions, one of your target should always be to have the LCM the same in the denominators on both sides. The moment you do not have this squared indicated here, it will mean that you are going to have different LCMs on both sides. So that means that when you start working out, things may not work out at all. You'll find yourself having fractions inside. I don't know whether you have got the point.
Yes, teacher.
And now even I want you to know that the moment you don't put the else, let me say the way you want to do it, when I have x minus 1 plus b out of x minus 1, hope you know mathematically, this is the same as a plus b out of x minus 1, mathematically. Because the moment the denominators are the same, you just add the numerators. So this one would not be equivalent to what you have on the left-hand side. Like when you have 1 out of 2 plus 1 out of 2, you know this is going to be 2 out of 2. Let me just put here 3. So it will be 5 out of 2. Because the moment the denominators are the same, just add what you have. So if this power is not there, it means you just add what you have in the numerators. So you'll find that it's not going to be equivalent to what you have the other side.
Okay, thank you, teacher.
Okay. I think we are good to continue. Okay, we continue to the next one. Now, the next one, I want now to mix two things. I'm going to mix two things, Yeah. Our third activity. Our third activity, we are going to have x out of x plus 1 into x plus 2 squared. Now, here, one, you have linear factors, but one of them is repeated. What are we going to do? We are going to still apply the same thing. Deal with it at once. So what am I going to have? I will say this is equivalent to my a out of x plus 1. Now I'm dealing with this first one. Then I go. When you look at the second factor here, it is a repeated factor. So I will say plus b out of x plus 2 plus c out of x plus 2, everything squared. Kindly let me know in the chat whether that step is okay. Are we there? Good. Now, the moment you have it up to that point, it means that now we are good to continue. So what have we said? We have said when you reach here, after that, you are going to multiply. Say, multiply through by whatever you have in your denominator on the left-hand side. So this is what we have in our denominator. So it's like your LCM. It's what you are going to multiply with. So you multiply it throughout. So I'm going to come here. You are going to allow me, I'm going to, for you, those now who have picked, you can even continue. You don't need to wait for us. So this is going to be a into x plus 1 plus b out of x plus 2 plus c out of x plus 2, everything squared. So you are going to multiply all through. So here I will multiply by x plus 1, x plus 2 squared. I will come here x plus 1, x plus 2 squared. This is going to be x plus 1, x plus 2 squared. X plus 1, x plus 2 squared. Now, the moment you reach there, then you are going to find yourself that cancelling x plus 1, x plus 1, x plus this, come here. this and this will go. Come here. Now here you be very careful. Up there 2, down it is just 1. So here I remain with 1, but one of them will go. Here, this and this is going to die. So now I'll have something like this. Hope we are still on the same page. So this side I remain with x equivalent to a into x plus 2 squared plus b into x plus 1, x plus 2, x plus 2, then plus c into x plus 1. Hope we are still together. So that is what we have. Now, the reason why we are squaring the factor of c, remember the previous numbers we have looked at, I showed you that whenever you have a repeated factor, this is 2. It means you are going to separate 2 times. That is like the meaning. In case this is power 3, you separate it 3 times. So it depends on the power. That's why we keep on separating it. And yes, and I told you that why we keep on those squares is we want to maintain the same LCM on both our left-hand side and on our right-hand side. Now, when you reach here, members, feel free to use any approach of your choice. But do not forget, the moment you decide that you are going to use the equating coefficients, you have to expand these brackets. But me, I don't want to go that side. I want to use the substitution. So I'm going to first say, now I start with one of them. I can start with x plus 1. So I say, let x is equal to -1. Hope members have seen where I'm getting the -1. I'm going to say x plus 1 is equal to 0. I'm starting with this factor. So my x will equal to -1. Therefore, I'm going to substitute it on both sides. Wherever there is x, I put -1. So I'll have -1 now equals to a into -1 plus 2 squared plus b. Here I have -1 plus 1, -1 plus 2 plus c into -1 plus 1. You are going to notice -1 plus 1. Here, it's going to give you a 0. And anything with a 0, it means that the whole of this one is going to go away. Here, you'll also get a 0, so everything will go away. So meaning, I'm going to remain with -1 equaling to a into -1 plus 2 gives us a 1 squared. So that means I'll have -1 is equal to 1 squared is 1, 1 times a. So I'll have my a as -1. I don't know whether you're getting -1 or not. Now, after getting, I don't know what people are getting, but that is it. Then I go to the next one. The next one, I can say x plus 2. Then I go, still you can do your side work. You say now x plus 2 equals to 0. So what am I going to have? X is equal to -2. So here now I'll come and say, for or let x is equal to -2. So you put where there is x, you put -2. So you shall have -2 equals to a into -2 plus 2 squared plus b into -2 plus 1, -2 plus 2, then plus c into -2 plus 1. Now, what are you going to notice? You are going to notice that -2 plus 2 is 0. So here we shall have a 0. So everything here is going to die away. You are going to come here, -2 plus 2, here you have a 0. Everything here is going to die away. So you remain with C. -2 plus 1 gives us -1. So this side, we are going to have C into -1. And this side I have -2. So I'll have -2 is equal to -C. Divide by -1, divide by -1. Our C will equal to 2. Okay. Let me task you now to find B. But in case you have a question from this point, kind of you can ask. People even have got C. That is good. Okay, now let me pick a hand as we complete to get B. Yes, Rajab. Yes, Rajab?
Sir, sir,
Yes, please.
good afternoon.
Good afternoon
I,
too.
I want to clarify. Since we got the value of A as -1, can we not substitute that -1 where there is A as we are finding the next letter?
It is very okay. It is very okay. Substitute. Yes, ITEL. Yes. Oh, sorry. ITEL. Oh, I'm not getting ITEL well. Okay. Why do we divide by, what is division? I'm not dividing anything by 0. Here, this one, there's nothing like division by 0 members. I don't know why someone's saying 0. Let me first, there's nothing. I was just showing you, what I was showing here is that -1 plus 1 is 0 here. So meaning you'll have b times 0 times -1 plus 2, which is a 1. So bit anything times 0, everything goes away. So the whole of this one here goes to 0. That's what I was saying. Even here, -1, this, everything here will go to 0. That is what I was writing. ITEL.
What I'm asking is, here, this what the beginning, we see that it is x over x plus 1 into x plus 2 squared. It is equivalent to 2 over x plus 1, then plus b over x plus 2. Here I thought that the c also have to be x plus 2. Now why are you squaring this factor of the c?
For C,
That is where I'm confused.
have you just
Yes,
joined?
this
Oh,
one here. From B,
like have you?
I joined like 20 minutes ago.
Yeah,
I
like we have
joined
said,
when you were starting this activity.
yeah, we have said why we square is that we want to ensure that the LCM we have on the left-hand side is the same LCM we have on the right-hand side. The moment you do not square, you are going to have something like this: x plus 1 plus b out of x plus 2 plus c out of x plus 2. What does it mean? The moment these things have the same factor, this is just an addition of saying just b plus c out of x plus 2. Now, when you look x plus 1 and x plus 2, you are going to notice that the LCM you have on the right-hand side is not equal to the LCM on the left-hand side. So, us squaring or putting the exponent there is that we are expanding, we are increasing the powers. That here, I'm going to start with the lowest, I'm going to start with 1, here 1, then I increase to 2 because it is 2 here. In case we are through, we said you add on and set d out of x plus 2 power 3. Let me hope you have picked something. Okay. People are getting b equals to 1. Okay. Now, for b, for me, I said you can let for you what you want. Now, people have said let x is equal to 0, which is okay. So I can say let x is equal to 0. So, yes, Paul.
Teacher, okay. Those of us who are using method 2, so you come to a step where, of course, you have to expand the brackets, and then now that the part for equating coefficients on the left hand side, we have only x, the coefficient for x. So for the coefficient of x squared and the coefficient and the constants, do we equate to 0?
Perfect, perfect. Yes.
Okay, thank you.
Okay. Okay. Now, those who have used 0 here, I expect you to have 0 this side. Here will equal to A, which you have already as -1 into 2 squared plus your B, which you are looking for. They allow me for me to just put the answers plus C, which is 2. Yeah. Then when you work out this, you will surely have your B. Your B equals what? To 1. Your B will equal to 1 when you work out everything. So that is, yeah, this is equal to 1. Yeah. So when you work out, now those who have, yes, B is 1. Then after, please, you come back and substitute. Come back and say now this is equivalent to A, which is -1 out of x plus 1, then plus your B, which is 1 out of x plus 2, plus your C, which is 2 out of x plus 2, everything squared. So that is how you expand. But now for this particular one, allow me to first support people who are using the second approach. Can I go to another screen? You can let me know in case you are finished. This screen, can I transfer to another screen? Okay. Now, for another, I wanted... Oh, okay. Okay, people, you first finish. I repeat, to obtain B, you can have any value of X you want of your choice, whether 1, whether 2, or whether 3. And then you are going to come here. For me, I decided to use 0. So here I will put 0 equaling to my A. We have already obtained A here, which is -1. Bracket, our X, we are using 0 plus 2 squared plus B, which we want. But our X we have said is 0 plus 1 into 0 plus 2. Then plus C, which was 2 into 0 plus 1. Now you're going to notice that 0 will equal to -1. Here we shall have 2 squared. Plus here will be B into 0 plus 1 is 1. 0 plus 2 is 2. Plus 2. 0 plus 1 is 1. Now what will you have? 2 squared is 4. So here I remain with -4 plus 2b plus 2 equaling to, this side will be 0. So -4 plus 2 gives you -2 plus 2b. So when you collect like terms, you'll have 2b equals to 2. You divide by 2, and your b will equal to 1. So that is what you do. Yes. Yes, baby.
Yes, sir. I wanted to know if you can also use the numbers which you had already used, like -1 or -2. Can you use them again?
You can't use them because you'll get a problem.
Okay.
You'll find the B you're not able to get it. Now, those who have used 2, still you must get the same. Don't go on and say I'm rounding off. No, there is a mistake you have made. So those who are using 2, this will be 2. Let me use another color. You have to get the same answer, not something equals to that. So this will be 2 equaling this side to A into 2 plus 2 squared plus B into 2 plus 1, 2 plus 2 plus C into 2 plus 1. So let me do it roughly. Here you have 2 is equal to A, which was -1. 2 plus 2 is 4. 4 squared is 16 plus B. 2 plus 1 is 3. 2 plus 2 is 4. 4 times 3, that is 12. Plus 2 plus 1, that is 3. That is 3 times C, which is 2. So you have 2 is equal to -16 plus 12b plus 6. What do you have? -16 plus 6 will give you negative what? That is -10 plus 12b. This side is equal to 2. When you take -10, this side you have 12 is equal to 12b. So your b is equal to 1. So there's no way you get an answer. For whatever value you use, you have to get the same answer. So Brenda, check out the mistake you made. Even if you use 10, Now, people talking about long division is used for improper fractions. We have not yet reached there. We shall get there. Okay. Yes, Itel. Okay. I think now we're on the same page. Allow me to remove this, and then I first support a bit people who have used the long division. Now, for people, still even this one will help everyone. When we have this, remember this was, I think, x plus 2 squared plus b, x plus 1, x plus 2 plus c into x plus 1. The first thing you do, first expand all your brackets. So this will be a, allow me to do it. This is 4x plus 4, then plus b. When you expand these two brackets here, I'll have x squared. That is 3x plus 2, then plus c into x plus 1. Then what you do, you can first open them. So this will be ax squared plus 4ax plus 4a plus, this is bx squared plus 3bx plus 2b, then plus cx plus c is equal to x. Then you start equating. That x squared, I have this x squared, I have this x squared. So what will I have? Here the coefficient is going to be, now equating coefficients, I'll have a plus b, but when you look this side, you don't have any x squared, so you equate to 0. It means that you have 0x squared, the coefficient is 0. Then when I go to those with only x, I have this, I have this, I have this. So I'll say, this side I have 4a plus 3b plus c, and this side I have only 1x whose coefficient is 1. I'll equate to 1. Then when I go to the one without, I have 4a, 2b, this was what? And c. So I'll say 4a plus 2b plus c, this side is equal to 0 because I don't have any constant. Then you solve these equations simultaneously. So the moment you solve them simultaneously, you use any approach you want, you'll be able to get the answer. So that's what you get when you, yes. Ian, you can use any number. Okay. Class, can we continue now? Which part? Mona Lisa, which part? I don't know where you want me to repeat, but Mona Lisa, which part do you want us to? Pardon?
Sure, the third step, from the third step.
From how we equate the coefficients?
Yes.
Okay, now this side, when I collect like terms, I have x squared here, I have b squared x here. So I can first bring them together. Then I have 4ax plus 3bx plus cx. Then I have 4a plus 2b plus c. Now I'm just collecting like terms. Now when you come here, you notice x squared and x squared is common. So I can remove it. So I can say a plus b, everything into x squared. Then when I come here, x is common, x is common, x is common. I can remove it. So I have 4a plus 3b plus c, everything into x. Then here I remain with 4a plus 2b plus c. Now, on this side, I have only x. There is nothing with x squared, meaning that anything with x squared, it means that its coefficient was 0, because we know 0 times x squared is 0. So we don't need to write it there. So I'll get this coefficient, I equate to 0. When I come to the one with x, this side I have x, but the coefficient here, there is an hidden 1. So I'll have 4a plus 3b plus c is equal to 1. Then when I come here, this is a constant without x. And when you look this side, you don't have anything without x. So it means that it is also 0. So I also equate that one, 4a plus 2b plus c equals to 0. Let me hope. And now we're on the same page. So class, are we good to continue? Are we good to continue? You can let me know. Okay. Yeah. So this method of equating, you can weigh and see which one is going to be a bit easy, which one will not take a lot of your time, because at the end of the day, you not get any extra time. Okay, I think we wait for members to come back. Should we continue class? You can let me know through the chat. Okay. Yeah, I think something has happened. I don't know whether all those people who have gone off were using MTN. Would it be MTN challenge? Because I saw people dropped off. Okay, but also I went off. Okay. Now, I was still talking about the quadratics. Now, we are going to meet quadratics that we cannot factor. An example, take an example. You can meet such a number, x squared minus 1. Let me say x out of x squared minus 1. Members, when you look at this is a quadratic expression. But this kind of quadratic expression can be factored out. You can factor it. So that means you can write it as x out of x minus 1, x plus 1. So here you continue with the first approach, the two factors that are not repeated. Then you are going to meet quadratics of this nature, x squared plus 1. Now, when you look at this one here, you cannot factor. There is nothing you can do to factor it out. Now, the third case we are looking at those quadratics you can't factor. Even if you think how many times, you will find yourself that you cannot be able to factor it. So those are the ones we are going to look at. So whenever you meet that quadratic, for you need to check out, can I factor it or I cannot? Be it even when you meet something like this. Take an example. When you meet x squared plus 2x plus 1. This one is a quadratic. But when you look at it, this quadratic can be factored out. Now, what is one of the easiest way to do it? What you do on your calculator, you go to your calculator and you first assume as if you are solving an equation. You know how to solve equation. So you place it in your calculator. The way you solve, you say now x squared plus 2x plus 1. When I equate to 0, when I solve using the calculator, can I be able to get an answer? The moment you find that you are able to get an answer, it means that that quadratic can be factored out. So that one, you are not going to use this approach. But the moment you find that, take an example, you solve this one will give you what you call complex roots. So when you place it in your calculator and you want to solve using a calc, your calculator will give you I. It will put there I. Sometimes depending on the kind of calc you have, it even can give you math error, depending on the nature of the calc. But here, it will give you a complex root. Now, what are we going to look at? we are going to look at those quadratics that we cannot factor. The moment you check that you can't factor it, then you have to go on and do what? And use this approach. Let me hope we're on the same page. Class, are we together? Are we on the same page with that? I've said, how do we know that we cannot factor it? The moment you find that you cannot find the solution to that particular one. The moment you find out that you cannot find a solution. Imagine, yeah, like take an example. When they tell you to solve this equation, x squared plus 1, what will happen when you are solving? You say x squared is equal to negative 1. Then you have to take a root, but you cannot have a negative root. So this is what you call the imaginary roots. So you can't solve it. There are those things you are going to meet. Take an example. I can say x squared plus x plus 1. Take an example this. You try to solve this equation and tell me whether you are getting some answer. X squared plus x plus 1. What do you have? You test that one. I've told you, you must be able to know how to use the calculator. For many of these quadratic ones. You'll find that you are getting imaginary.
Recording in progress.
Just give me a minute as you do what? As you first make some small notes on this slide. So, yeah. So the moment you find that you are getting I's, it means you cannot be able to solve it. Like you cannot be able to factorize it out. So here we are going to be dealing with such equations. But I've said one way to test it, and you'll find that for some equations, you can be able to get one root, and you may not be able to get the other root. So we are going to see how do we solve them. Now, such equations or such proper fractions that you cannot factorize, this is how we do approach them. For it, the key thing I want you to observe, for that quadratic factor up, we shall always have bx plus c. I can give you an example. Yeah, now for you, check it out. And for it, you'll find things like x squared plus 2, such. So take an example. You can have a number, they can give you x out of x plus 1. Let him x plus 1, then they give you x squared plus 2. Now, still here, you notice this one is a linear factor. So that one, you know what to do. You say out of x plus 1. Then plus, the moment you find this one with a quadratic thing, what you do, for it, we shall always write it as bx plus c out of x squared plus 2. Yeah, so please, that one you have to take note. Whenever you look at the denominator and you check out that that denominator is a linear factor, is a quadratic factor, then that is how you approach it. Okay, but I've said, let us now summarize something on this slide and then we continue. But in case you have any question, feel free to ask. Hope, Priscilla, we are on the same page.
Yes.
Going Esther, are we on the same page? What about Paul Wura? Benjamin, hope we're on the same page. Martina, hope we're on the same page.
Yes, teacher.
Yeah. Pearl, did the number come out?
Yes, it did.
Okay. Emmanuel, hope we are on the same page.
Yes,
And
sir.
Diana. Faith, are we still together? Alice Favor, hope we're on the same page. Okay. I think we are good to go. Paul, you have a question?
Yes, teacher, I have a question.
Yes.
Teacher, which scenario can require us to use what we are learning, like to work it out? Like, in which topic can that maybe scenario come from?
Now, that topic, one of them is going to be when you reach integration. When you start covering series, you can apply these quadratic, partial fractions. Now, like you have seen that even here, you are applying the knowledge of spontaneous equations that you covered. So when you are going to be covering integration, because I know it's one of the topics you are supposed to cover very soon, you'll be using it.
Okay, sir. Thank you, teacher.
Okay. Yes, Pearl.
Yes. Okay. So my question is now, if the denominator has 3 terms, okay, just know. Okay, yes, and then you're supposed to like separate it into 3 partial fractions, right? So since you already have bx plus c on the second partial fraction, which letter will you use to represent that the numerator for the third term? Will you use d or will you just
You have the answer. You use
d?
And in case it is quadratic, yeah. So you continue like that.
Okay, teacher.
Okay. Now, please take note that some of the knowledge you are learning now, you are going to be applying it. You're going to be applying it. In fact, you are going even in paper 2, you'll find no, in fact, let me not mention paper 2. In applied mathematics, you are going to look at different ways, but this topic is going to be very important in integration. Yeah. Even remember in numerical methods, you'll find the same when you are looking at those trapezium rules and the rest of that. Yeah, percentage errors and the rest. You'll find yourself in need of this paper. So the first one we are going to try out is here. Now, when you look at our denominator, you notice we have a linear factor, but one of them is quadratic. Meaning the moment you notice like a power 2, that one is just enough to give you a hint on what to do. So we shall say this is equivalent to, when you look at the first one, that one, you shall have a out of x plus 3. Then plus the second one here, we shall have it as bx plus c out of x squared plus 1. Now, after doing so, I've already told you that here what you do, for you, look at what you have on your left-hand side is what you multiply throughout by. So I'll say multiply through by x plus 3, x squared plus 1. So I'm going to come here and I do the same. I'll have 2x squared plus 5x plus 7 into x plus 3, x squared plus 1, equivalent to a out of x plus 3, then plus bx plus c out of x squared plus 1. So we are going to multiply it. So this side, I'll have x plus 3, x squared plus 1. Here I'll have x plus 3, x squared plus 1. Here I'll have x plus 3, x squared plus 1. Always please make sure you do not remain with anything in your denominator. So what will happen? This and this will cancel, this and this will cancel. So we shall remain with 2x squared plus 5x plus 7 equivalent to x plus 3 and x plus 3 will cancel. You remain with a into x squared plus 1. Then plus this side, you're going to remain with bx plus c. Then x squared plus 1 and this will cancel. Then you'll have x plus 3. Now, the moment you reach there, use any approach of your choice you want, either substitution or you can use the relating the coefficients. But allow me that I'm going to stick to 1, but it is okay for whatever approach you use. It is very okay. The one for you have mastered well is the one you go with for. Now, I'm going to look at one of the factors. Now, when you look at one of the factors is x plus 3. So we said you equate to 0 and have x is equal to negative 3. So that means that the first thing you're going to let will be x is equal to negative 3. Remember your target, your aim is to make sure you have A, B, and C. Now, the moment x is equal to negative 3, I'm going to substitute throughout here and this side. So I'll have 2 into negative 3 squared plus 5 times negative 3 plus 7 equaling to A, which I don't have, negative 3 squared plus 1 plus B times negative 3 plus C into negative 3 plus 3. Now, what do you take note of? You take note of that this one is going to be 0. Negative 3 plus 3 is 0. So here, 0 times anything will go away. Okay, but let me first pick this hand. Yes, Precious.
Excuse me, teacher. On this part that you multiplied the 2x squared plus 5x plus 7 divided by the x plus 3 into, again, x squared plus 1, whereby you took it the other side and this side to the method. Why didn't we just, like, though we equate this to this and then you just multiply this onto this and this to this? Doesn't it? And then we cut out this, like the we were doing before. Doesn't it lead us to this? Of
it is the same thing. It is the same thing.
It's the same thing.
Yes.
Thank you, teacher.
Okay. So here, members, negative 3 squared will give you, that is 9 times 2, which will be 18. Then plus 5 times negative 3 is negative 15 plus 7 will equal to A, negative 3 squared is 9 plus 1. And please, those people who use the calculators, here you be very careful. Your calculator may give you a wrong answer if you don't know. Whenever you're placing a negative in the calc, put a bra and a cat and then square it very well. So here I have 18 minus 15 plus 7. Here, members, I'll have 10 equaling to A times 9 plus 1 is 10. So I'll have 10 equaling to 10A. Divide by 10, divide by 10. My A will equal to 1. Now, after obtaining my A, I am going to go on and obtain my B and C. Now here, you must have a critical eye. You must have a critical eye. But one of the critical eyes is that I want to eliminate B. You tell me in the chat, in case I want to remove B, what should we equate to? Or what should our X be equaling to? Put your answer in the chat what you think. Perfect. You people are very, very bright. Yes. Yes, that is very, very correct. So we shall say, let X equals to 0, such that we eliminate the B. So you'll find that I'll have now 2 times 0 squared plus 5 times 0 plus 7 equaling to A, which we have already obtained as 1, into 0 squared plus 1 plus B times 0 plus C into 0 plus 3. So here is 0, 0. This side we shall remain with 7. Here I'm going to remain with 1 plus, here I'm remaining with C alone, then times 3. So this will be 7 equaling to 1 plus 3C. So you collect like terms, 7 minus 1 equals 3C. 6 is equal to 3C, and therefore my C will equal to 2. Yeah. So you have obtained your A, you have obtained your C. So the next one is finding out what your B is. Now for that one, always feel free to use any value apart from the factors themselves. Take an example. You cannot equate x squared plus 1 to 0 because you'll get an imaginary root. So for that one, feel free to use any value of your choice, whether you have used, as long as it's not -3, as long as it's not 0. If you want, you can use 1. But always I advise, let us use smaller digits that will not disturb us. So for me, since I want smaller digits, I can say let x equals to 1. So on my left, I'll have 2 into 1 squared plus 5 times 1 plus 7 equaling to A, which we obtain as 1 squared plus 1. Oh, my thing may not fit well. Into B, which I want, times 1 plus C into 1 plus 3. So this side, I'll have 2 plus 5 plus 7 equaling to 1 times 2 plus B plus C we have as 2, then into 4. So then you are going to collect your like terms there. So let's collect our like terms. This side I'll have 14 equaling to 2 plus, here I'll have B plus 2 everything into 4. Now when you open brackets here, I'll have 14 minus 2 gives us 12 equally. Yeah, okay, I've jumped a step there, but it is okay. Here I'll have 4B plus 8. Then for you, do your mathematics. And kindly let's convince ourselves that B is 1 also. Me, I've got 1. So convince yourself that also B is equal to 1. Yeah. Okay. So convince yourself slowly that B is equal to 1. But in case you fail, you can let us know, and then we help you. In case you are not getting B is equal to 1. But if we are getting 1, that is very good. Okay, I find that is okay. Yes, we have said now for equating, you do the same. But for equating, you first open the brackets. For equating, you can first open the brackets. So for equating, you do like this. This side, you have 2x squared plus 5x plus 7 equivalent. You open your brackets. This is ax squared plus a. Oh, Okay, let people first finish and I show you for equating on the next page. When you finish, you let me know such that mastering both approaches, it is okay. Yeah. Okay. Yes, iPhone.
So are we also going to look at a case where we have a quadratic factor in the denominator, but it can be factorized?
Yes, but I've already given you one example, but I'll show you one. No problem.
All right.
Okay, let me hope members have finished to write this and then I show you the other approach. Okay, people have finished. Some, I think. Yeah, but you can take a screenshot. Okay, now for the other approach, those who are using the equating approach, we have this. You have 2x squared plus 5x plus 7 equivalent to a into x squared plus 1, then plus bx plus c into x plus 3. I think that is what we have. Now, what do you, just confirming, okay, that's what we have. Now, what you do, you open your brackets. So here, we shall have ax squared plus a. Because this a will multiply here, this a is going to multiply the 1. Plus, you open the brackets here. These ones, you open them the way you open your brackets, this is x plus 3. The whole of this one multiplies the x in simple terms. So you can have bx into x plus 3. The whole of this c multiplies plus c into x plus 3. So when you open, you'll have bx squared plus 3bx plus cx plus 3c. So that is what we are going to put here. So we shall have bx squared plus 3bx plus cx plus 3c. Now you start collecting like terms. With x squared, I have this, I have that. So I'm going to put them together. So I'll have this equivalent to a x squared plus b x squared. Then I bring those without the x's. Sorry, with those with x, I have this and this second. So I'll have 3bx plus cx. Then those without x, I have a plus 3c. Now you can factor them out. So I have a plus b, and the common factor is x squared. For this one, I have 3b plus c, and the common factor is x, then plus a plus 3c. And this side, we have 2x squared plus 5x plus 7. Now, the moment you reach here, you equate x squared goes with this x squared. So those who want to visualize it, you can say 2x squared is equal to a plus b x squared. So this and this cancels, so you remain with only 2. So here we shall say a plus b equaling to 2. Then x and x. So here we shall say 3b plus c is equaling to 5. Then the last one, a plus 3c, a plus 3c goes with the 7. Then you solve these equations spontaneously. Now, when you are solving spontaneously, you can first do the elimination method. Take an example. I can get the first one and then the last one. This one. I say a plus b is equal to 2. Then here, a plus 3c is equal to 7. What do I want to eliminate? A. So, same coefficients, you subtract. So, when I subtract, I'll have b minus 3c is equal to 2 minus 7, which is negative 5. Now, this new equation I have got, I'm going to combine it with the other one. So 3b plus c is equal to 5. Then you solve these two to get the values of b and c simultaneously. Then after you get the value of a. So that is how you do it when you are using that equating approach. So you find that the value of b, you are going to get the same answer with what we had at first. Class, are we good to continue? You can let me know and then we proceed. Okay, according to the chat, I think we are good to continue. Okay, so can we do one more? We can do one more in this same field. Okay, now our next one is here. 8 plus 2x minus x squared out of x minus 1 into x squared plus 2. Can we first try it, class? What do you think? Should we first try it as a class on your own and then we see? What do you think? Yes. Okay, yeah. Okay, let's first try it. Let us first try it on our own and then we see. Expand it, but in case you have challenges, you can let us know. But let me first allow you to try it on your own. Yeah, I'm seeing some answers coming out. Okay, 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 now allow me to also, okay, I'm seeing some good answers, Beth, Bashir. Yeah, I think we just need to, someone to take us through. Anyone who wants to take us through? Okay, so, is it? Yeah, that one.
Melissa. Good afternoon,
That is Melissa.
everyone. Yes.
Okay, okay, Melissa.
So I use the second method.
Okay.
So what I did, I first multiplied the denominator.
Oh, can you first break for us the first part here, Melissa?
Where?
Are you seeing my screen?
Yes.
Okay.
Oh, so A over x minus 1 plus bx plus c divided by x squared plus 2. So I multiplied through.
Yeah.
Then it was
Okay. Give me what you got after multiplying through.
8 plus 2x minus x squared is equal to A into x squared plus 1 plus 2 plus bx plus c brackets, open brackets, x minus 1. Then 8 plus 2x.
Which approach did you use?
The second one.
Okay, Melissa, we continue.
Minus, So ax squared plus 2a plus bx squared minus bx plus cx minus c. Then ax squared, I collected like terms, yeah? Ax squared plus bx squared minus bx plus cx plus 2a minus c.
Yeah.
So a plus b, you close brackets, x squared. Then minus b plus c into brackets, x. No, this should be a plus c.
Like that?
Yes, then you put brackets. then
Like
plus 2a minus c. Then you equate
okay.
a plus b is equal to -1 minus b plus c is equal to 2. 2a minus c is equal to 8. When you solve them simultaneously, you get a as 3, b as -4, and c as -2.
Your conclusion was?
My conclusion was 8 plus 2x minus x squared divided by x minus 1 into x squared plus 2 is equivalent to 3 over x minus 1 plus, plus -4x plus, sorry. Divided by x squared plus 2.
Okay.
And
Can you
then
write it better?
that is 3 over x minus 1 minus 4x minus 2 over x squared plus 2.
Beautify it more.
Yes?
Beautify it more.
I think I stopped there.
Because this statement here may bring challenges. I want you to remove these negatives, factorize out the negative, and bring some plus here.
See, I put a plus between 4x plus 2.
Yes, I want a plus. I want us to factorize. Are you seeing -1 and -1 common?
Yes.
So
it should
can we
be,
fact?
I create brackets. That will be minus 4x into brackets 4x.
Plus?
Yeah, plus 2, but you should create brackets there, yeah.
Yes. Now this one it looks very beautiful.
Okay.
Well done. Thank you, Melissa. Okay. So members, that's how we can have that answer. Yeah, you can, in case those are the answers you have, that is very correct. So those who have used the other approach, still you must get the same answers. Okay. Now, why don't you allow me to give you some exercise to try out? Yeah, so you can take a screenshot. Yeah. You can take a screenshot, you try out those numbers. Now we are remaining with just one case, and that case is the one for improper fractions. What are we going to do? Now, in case time allows, I can, do you have tomorrow? Okay, in case time allows, what I'll do, I can shoot a small video about improper fractions. Or you can suggest time in the chat when we can have that mini lesson for only improper. Because for us to say we are done with partial fractions, we must look at that improper part. So you can suggest the time when we can have that. It can only take us 1 hour. And then we shall say, at least we have sealed partial fractions. So you can suggest, oh, now Melissa extending it now. People are, I feel they are tired. So I want them at least to, I want them to do what? to take in a bit of, to first complete these numbers. Oh. Mm. Okay, but I think we shouldn't do it today, such that at least you first master this first part, eh? Tonight. Okay. 8 p.m. Okay. Okay. Yeah. Okay, but I know we shall have it tomorrow. Okay, we can have it tomorrow. Oh, tomorrow is Thursday. Okay. Okay, people are suggesting tomorrow. Okay, I'll let you know on what I would have decided on, whether we can have it tomorrow, in case my program will allow, tomorrow or Friday, one of those days. But we shall complete that part because it is the only part that is remaining about improper. And then we shall have sealed this topic. Otherwise, I want us to end here. For now, I'll share this in your in the group such that you can be able to look at it. Yeah, so we are remaining on how to decompose improper fractions. But as we are preparing for that lesson for improper, the major thing you need to know is going to be long division. We shall first look at how do we turn an improper into proper, and then we continue. Yeah, we shall look at long division. So let's prepare either tomorrow or Friday, but we shall use time. I think we may look at around 10, 11, 12, around that time. So prepare yourself around that time, either tomorrow or Friday. But in case I don't communicate anything on the group today, then it means we shall have it on Friday. In case I don't make any communication today about the lesson, then just know we shall have it on Friday. And then what I'm going to do for these numbers, I don't know what time you want me to send you the solutions, but I think I can send them at around 8 today, and then you check out whether what you have done is correct. But I'll send them today. Okay, Rajab, you have a question?
Sir,
Mm.
I'm just inquiring if you can formulate for us some scenarios on that topic.
Yes, we are going to first complete. The moment we complete, then in case time allows, we shall have a session when we shall only be looking at those scenarios. But I want us to first master the concept, and then we can be able to apply it in the scenario.
Okay, sir. Thank you.
Okay. Yeah, but also I remind you, please, that some of these topics that you are going to look at, the scenarios will be able to come out very well when you have started this, when you have done these topics: differentiation, integration, and trigonometry. Yeah, some of these concepts you are going to meet in algebra. Their application is going to come out when you have completed the topics of integration, and expect a lot of application questions in integration. Expect a lot of application questions when you look at differentiation. When you start differential equations, yeah. So you are going to find a lot of applications within those areas. But those areas will require you to have mastered simultaneous equations, your algebra, partial fractions, and the rest of that. Yeah, but I will generate some scenarios for you to be able to apply. Otherwise, thank you so much for attending. Let me wish you a good afternoon, and bye-bye, everyone. Enjoy your evening. When you complete, you can share with me. I can look at your work, but also I'll be sharing the solutions in the... Oh, in the chat. Those who are going back tomorrow, we wish you a good, wish you safe journeys. Yeah, see you next time. Audios. Oh, we shall send the recording in the chat. iPhone, what are you saying? You can unmute. I've allowed you to unmute members. Okay.
I'm requesting for your number. Just in case I want to share the solutions with you.
Okay. 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 But are you in the group?
Yeah.
Yes. Yes. Yes, you can send me on that number on the group.
Okay, sir.
Okay. Okay.
Thank
The
you
link
so
I
much.
think has been shared. The link has been shared. Yeah. And please, members, those groups are the same, eh? Yeah, the groups are the same. In case you are, let me see. The groups are the same. So we share the same content on all groups. Yeah.
Yes.
Then we shared some material. Those who are doing biology, you are doing chemistry, please, you can utilize. Though what I want to tell you that those are not the final ones. So that is the group link. Otherwise, have a good day.